Yeah, so our diagram shows 4 trapezia. So using 4 trapezia, we have the area will be a half h y1 plus yn plus 2 y2 plus y3 plus so on yn minus 1. So in our case, area is equal to a half. The width is 1 unit. Y1 is equal to 8. This is 8. Yn, which is the outer length, is equal to 32 plus 2, the inner bounded lengths, 11 plus 16 plus 23. So when we simplify this, we get a half into 40 plus 11 plus 16 plus 23 plus 100, and this gives us 70 square units. So that is the approximate area when we use 4 trapezia. In the case of 8 trapezia, we divide the 4 trapezia into 2 each. So we'll need the midpoint of the first trapezia, the midpoint of the second trapezia, midpoint of the third trapezia, midpoint of the fourth trapezia. So we need these lengths, which correspond to 0.5. So substituting 0.5 into the equation, we'll have 10.25. Then corresponding to 1.5, we'll have 13.25. Corresponding to 2.5, substituting into the equation, gives us 19.25. And then corresponding to 3.5, we have 27.25. So we have the dimensions of the 8 trapezia. So for part B, for part 2, using 8 trapezia, 8 trapezia, we substitute into our equation and we get our area is equal to a half. For this case, the widths are 0.5. So that is a half times 0.5 into 8 plus 32. These are the outer boundaries, plus twice the inner boundaries. That is 10.25 plus 11 plus 13.25 plus 16 plus 19.25 plus 23 plus 27.25. And when we evaluate this, we get plus 13.25 plus 16 plus 19.25 plus 23 plus 27.25 times 2 gives us 240 plus 40. So we have 0.25 into 40 plus 240. And this gives us 70 square units. So the two answers, when we use 4 trapezia and when we use 8 trapezia, we get the same answer.